This is an introduction to graphing square root functions. So first of all, the parent function for a square root function will be given by f of x is equal to the square root of x. This is the first time we've seen a parent function that does have restrictions on its domain. Polynomials don't have restrictions, absolute value functions don't have restrictions, linear equations don't have restrictions, but square roots do. So the domain of the parent function, square roots must be non-negative. So we would say that the domain goes from 0 inclusive up to infinity. And then if you recall the different types of transformations that we see on parent functions or anything that's in some kind of standard function form, you can apply those same transformations to that square root function. So much like when we looked at cubic functions, if you saw that video, cubic functions, we don't have a vertex form necessarily. However, if it's written in quote-unquote vertex form, you can use those same types of transformations to move the graph in the coordinate plane. Same thing with the square root. There's no such thing as vertex form. There's no vertex. However, there is a starting point. And that starting point can maybe help us figure out, once you know the starting point, which would be the beginning of your domain, you can kind of build the graph from there. But I'm getting ahead of myself. Let's just look at the graph of the parent function. So we want to fill in the table and then sketch a graph of f of x equals the square root of x. What would be some good x values to use? Usually I say -2, -1, 0, 1, and 2. I'm not going to say that in this case because -2 is not in the domain. Let's just use some of the numbers in the first few integers in the domain. So 0, 1, hold on, I want to be really careful here. What's going to happen if I use 2? So let's start filling in the table and then we're going to fill in a few more x values after. So 0, I plug in 0 to my parent function, the square root of 0 is 0. Plug in 1 to my function, square root of 1 is 1. I go to plug in 2, the square root of 2 is the square root of 2. Ew. Well, I'm probably not going to graph that. So here I want to be very careful about what values I choose to use for the domain. I don't want to use just these normal integers. I want to use specifically ones that I can take the square root of and it's not going to be something horrendous. So what's the next number after 1? I probably want to use the next perfect square, which is 4. And the square root of 4 is 2. And then after that, I'm going to skip down to 9. The square root of 9 is 3. That's all my graph will allow, so I'm actually going to stop at 9. But of course, the next one would be 16, 25. Those are the values we want to use, so that way we have nice numbers to plug in on the graph. Okay, so starting at the origin 0, 0. That's the first point of this graph, and then 1, 1. I'm going to skip 2, radical 2. I'm not going to find radical 2 on my graph. And then 4, 4, 2. And then 9, I think I went up to 10, so 9 would be here. 9, 3. And so what the graph is, it's a curve. As you may know, I am not very good at drawing things. So it should be just a nice curve. The curve is increasing. It's taking a while because everything's it's the square root, so it's not moving very quickly, but it is increasing. Well, that wasn't so bad. And so that would be our parent function. In the next video, we're going to look at some transformations.